A robust earthing system is crucial for the safety and longevity of a rooftop solar power system. It protects against electrical shocks, lightning strikes, and equipment damage. Well, in this video, let's explore the detailed process and sequence for making good earthing for a rooftop solar power system. Let's begin with the site survey and planning. This is the most critical first step. Soil resistivity varies greatly and directly impacts the design of your earthing system. Multiple measurements should be taken across the site at different depths. This data helps determine the types and the size of the earthing electrodes needed. Understand the capacity of your solar system to determine the number and the type of earthing points required. For example, 1 kilowatt to 3 kilowatt typically requires two earthing points, one for the inverter and the other for the lightning arrestor. And the installations above 3 kilowatts generally needs three earthing points, one for the inverter, one for the lightning arrestor, and one for the additional one for the solar PV modules. Identification of components to be earthed. This includes solar panel frames and mounting structures like the DC earthing. Inverter chassis, this is for AC earthing. AC distribution boxes, DC distribution boxes, lightning arrestor if installed, any other exposed metallic parts of the system. Types of earthing. AC earthing for the inverter and AC side components. DC earthing for the metallic frames of the solar panels and mounting structure. This is crucial for preventing electrocution from fault currents in the DC side. Lightning arrestor earthing. A dedicated earthing system for the lightning arrestor is installed. This is essential for protecting the entire system from lightning surges. Earthing electrodes. Choice of material. Copper is generally preferred due to its low resistivity and corrosion resistance. Though galvanized iron is also used, copper is more expensive but offers better performance. Pipe earthing, commonly used, involves burying galvanized steel or copper pipes deep into the ground. Plate earthing, copper or GI plates buried deep into the soil to prevent static charges and stray currents. Chemical earthing utilizes chemical compounds like bentonite or backfill compound around the electrode to reduce soil resistance and improve conductivity. This is highly recommended for long lasting performance. Number and spacing of electrodes. The number of earth pits and their spacing, typically more than the twice or one and a half the times the length of the electrodes, are determined by the soil resistivity. Conductor sizing. Body or equipment earthing typically requires 16 square mm wire copper cable. Lightning earthing minimum 35 square mm pipe cable or copper strip, potentially up to 70 square mm depending on the system and lightning risk. The grounding cable for PV modules should have a minimum cross sectional area of 6 mm square. If the cable length is less than 30 meters and 10 square mm, if more than 30 meters. The grounding cable for PV panels should have a minimum cross sectional area of 6 square mm. If the cable length is less than 30 meters and 10 square for the 30 meters and above. Target earth resistance. In India, the recommended earth resistance for solar installation is generally less than 5 ohms. For lightning arrest, it's typically less than 10 ohms. Installation process. Digging the earth pit. Excavate a pit of appropriate dimensions, typically 2 to 3 meters deep for each earthing electrode. Electrode installation. Install the chosen earthing rod or plate vertically into the pit. Chemical filling if applicable. If using chemical earthing, fill the pit with appropriate chemical compound, bentonite or BFC, charcoal salt, around the electrode to enhance conductivity and maintain moisture. Connections. Panel frame bonding. All metallic frames of the solar panels in an array should be interconnected and bonded to the DC earthing system. This can be done via the mounting structure if it is designed for electrical continuity or with dedicated grounding clips, plugs, and a continuous copper earthing cable running along the panel rows. Inverter and electrical equipment bonding. Connect the chassis of the inverter, ACDB, DCDB, and other metallic enclosures to their respective earthing points using appropriate copper wires or strips. Lightning arrestor connection. The lightning arrestor, if used, should have a direct, low resistance path to its dedicated earth pit. Use anti-corrosion materials for all connections, lugs, clamps, connectors. Ensure proper tightness to prevent loose connections and corrosion. Crimp the cables properly. Ensure earthing cables are routed safely, protected from mechanical damages and environmental exposure. After installation, it's crucial to measure the earth resistance using an earth resistance tester. The measured value must be within the acceptable limits, typically less than 5 ohms for equipment and less than 10 ohms for the lightning arrestor. Maintain detailed records of the earthing system, installation, and test results. This is vital for future maintenance and compliance checks. Conduct visual inspections of all earthing components at least once a year, more frequently in corrosive environments, for signs of corrosion, damage, or loose connections. Any identified issues like broken conductors, corroded terminals, or high earth resistance values should be addressed immediately by a qualified electrician. Yes, by following this comprehensive process, you can ensure a robust and effective earthing system for your rooftop solar power plant, providing essentially safety for personal and protection of your valuable equipment. Always consult a qualified electrical engineer for the specific design and installation of your earthing system. I hope this video enlightens you about the proper earthing system for your electrical requirements. Thank you. This is Srinivas from Dolphin Coverage Solutions. Quality and safety assured.